In the previous video, we studied about the brief of feature engineering and what are the several methods by which it can be implemented. And now we are going to see one of it, that is outlier detection and removal using standard deviation in Python pandas. So for that, we are going to use a weight and height dataset, which is there, a CSV file, and that we have downloaded from Kaggle. So you can simply download this, it will be a zip file, and then you can extract the CSV file which is there. Now here you can see in detail two unique values which are there. Firstly, the genders which is there, that is male and female, and then the height count is there, and similarly the weight count is there. Now what I have done preferably is that I have dropped the weight column and taken only the height column. So firstly, I have read the CSV. After importing and extracting, you can simply import that file for the current session over here, and then you can give the path over here for reading that file. Then you can drop that particular column of weight by simply writing del or the drop command which is there, and then I have determined the shape. Here you can see there is two columns which are there, and then I have shown you the first 5 entry which is there of the gender and with respect to their height which is there. This is the thing which we have done till now. Next, I want to visualize the height which is there actually in inches, and then I want to see the count also. So for that, what we are going to do is we will be plotting a histogram which is there. So what we used to do in matplotlib for plotting several graphs, same we are going to do here. So for plotting a histogram, we used to write plot hist. Similarly, we're going to write here plot hist, and then we have to give here which particular column we are using. So we are using df dot height, and next what we're going to be using is we have to mention the number of beans which we want to give. So that I'm giving here as 20, and next we're going to give the width also. So for that we have r width, and I'm giving the r width as 0.8. Next, what we need to do is now we have to give the labels, and lastly we have to write plt dot show for the display. So firstly, we're going to give the label for the x-axis which is there. So that you have to write simply like this, plt x dot label, and here you can mention the label which you want to give, such as I want to give here heights and in inches. So this will be my label for the x-axis which is there. And similarly, I'm going to mention a label for y-axis also. So plt dot y label, and there will be the count of the particular person which are there. And lastly, we're going to write plt dot show. This sums up our code which we're using for visualization. And as I execute this particular cell, here you can see that it displays a histogram which is there, and according to the axis also which we have given that as height in inches and the count which is there. Next, to understand the concepts, or you can say the fundamentals about how a normal distribution happens and how we're going to plot a bell curve and the standard deviation, there you can see a very awesome article has been written here in Math is Fun. So you can refer this particular article for clearing the basic concept which are there. Now, Z population or Z bar we will be seeing next video, in our upcoming video, that we will be outlining with the help of a Z score, and what is it that we will see later on. But to understand about particularly standard deviation and the computation, you can refer to this particular tutorial or this website Math is Fun. So now what I want to do is I want to plot a bell curve. Now how actually a bell curve looks like, I will tell you. So in our histogram, this is the x and the y axis which is there, and here we have plotted several histograms like this. These are the bars which have been plotted. So what is actually in a bell curve happens is this curve goes like this and ends here. A certain figure of bell is drawn. So we're going to use that particular to draw the bell curve for the height and the particular histogram which we just now plotted. So for that, we have to import something that is norm from scipy.stats. Now scipy is basically used for scientific calculations which are there. I have discussed you while I was briefing you about some data science libraries which are there. So you have to write here scipy.stats, and from that you want to import norm like this. And then what you need to do is, now you have to import numpy as np also. And then you have to plot the histogram which is there. Same histogram you have to plot, and you can use the same code here also, which we have written here of the hist, and according to the curve which is there, that is the count in the y-axis and the height in inches in the x-axis. So same function I have used here, I have not changed anything. Now here one thing which I need to do is I have to make the density equals to true. And now next, for plotting the bell curve, what we need to do. Now RNG we will used when we are discussing about numpy, then we have studied about a function a range, and from there we define a maximum height which is there, and according to that we will be plotting a height mean and the standard deviation according to it. So here you can see by visualizing this graph only that this 65 to 66 we can see the mean height which is there. This particular plotting here you can analyze, but now we need to draw a bell curve for it. So for that we have to write simply like this: RNG equals to np dot a range, and then here you have to give df dot height. The minimum, firstly you need to give the height minimum which is there, and then you have to give the maximum which is there. So similarly, if you have written here min, then you can copy this particular and you have to just change here the max. That's how the curve is actually there. I have visualized you the curve also. And then you have to give a particular value of range, we can say that as 0.1. And next what we need to do, we need to plot this particular plot, that is PLT. So we will use PLT dot plot, and we are plotting the RNG, and with that norm which we have imported from the SciPy stats. So RNG norm dot PDF, and then what we need to do, we have to give the range height mean and the STD for standard deviation which is there. So this I have written, and as I execute this particular cell, here you can see a bell curve has been drawn. So these are actually the minimum values, and here you can see these are the minimum values and these are the maximum value which is there, and we can say that 65 is the mean value. Also we have studied about a function that is df dot describe. While we are discussing in brief about numpy arrays, then we have studied about df dot describe, and what it is to return us all the mathematical count which is there. So here you can also see the standard deviation is here, the minimum value is there, the mean count is also there. So we can say that this is the mean count. We can visualize with this also. So we have plotted a bell curve. Now if I want to check the height mean which is there, so that I have checked with the help of describe also, but I can also check that with writing similarly like this: df dot height, and then you can write here mean. And as you execute this particular cell, here you can see that 66.36 is the mean value that we have seen in the describe also. And similarly, if you want to write for the standard deviation, then here you have to write STD. And you can see that the standard deviation is 3.84, which we have also seen with the help of describe function. So here the mean is 66.37 and the standard deviation is 3.84. Now outlier detection and removal using 3 standard deviation. So what we will do is, one of the ways we can remove the outlier is to remove any data point that are beyond these 3 standard deviation from the mean, which means we can come up with the following upper bounds and the lower bounds which is there. Upper bound or upper limit will be +3 into df standard height and lower will be -3. So what we want to do is we want to remove these 2 particular sets which are not, we can say, that are beyond the 3 standard deviation from the mean which are there. So for removing the upper limit, what we need to write, we have to write like this. Let's say I'm creating firstly a variable up, and there I am using df height mean, and then what I'm doing is df height mean plus 3 into the df height STD. That with this we are calculating actually the upper bound which is there, the upper limit which is there, and then I want to print this upper limit. So here you can see that 7.9 is actually a deviation that is to remove any outer point which is beyond these 3 standard deviation which we have seen. Similarly, we are going to do for lower limit, but now we are going to do it with a minus, the negative sign. And then the outliers will actually be on 3 standard deviation from the mean. We are going to visualize them also. So for lower limit, I am creating a function LP is equals to mean and I want to remove it, so 3 into, this is for the lower limit. And lastly, I want to print this LP also. So this is the lower limit which is there. Now you want to visualize it. So for that, what you have to write like this, df, and the height of upper limit will be greater than the particular height which we are taking as the mean value. So for that, it will be like this, height greater than upper limit which is there, it is up, stored in up variable, and then we're going to use a pipe, and then you have to write similarly for df height of the lower limit also which is there. So this is the set, and as I execute this particular cell, here you can see that df entry of those particular, we can say the male and female which are there, where the upper limit is there of the height and then the lower limit has been displayed to you. So these are, we can say, are actually the outlier detection which we have done. So the above heights are higher end, that is 78 inches, which is around 6 feet 6 inch we can say. Now that is quite unusual height. There are people who have height but very uncommon. So it is okay to remove those data points. Similarly at the lower end also 54 inch, which is around 4 feet 6 inch. Now while this is a legitimate height, you do not have to find many people of this height. So it is safe to consider both the cases as outlier. Next, what we need to do is remove these outlier and generate a new data frame which is there. So we want to generate a new data frame, so that I am naming here as df1, and then what I want to do is I want to remove both these outliers which are there. So here you can see that I have removed those data frames which are there, we can say the entries which are there, and check the shape. So it returns me that 9993 is the shape of this df1, where height less than upper limit and greater than lower limit is there. And when we check the shape of the original data frame, that tends to be 10,000. So this shows that the original data frame has 10,000 data points. Out of that, we have removed 7 outliers which is there. That is a subtraction of 10,000 from 9,993. So this we have seen that how can we actually draw a bell curve and how can we actually do the outlier detection and removal using standard deviation. In our next video, we will be discussing that what is z-score and how can we detect the outlier and remove it with the help of z-score.